Today, we're looking into the world of plants. From the tall to the small, and everywhere in between, we're going to be using a device that measures the electrical impulses of plants to get further information on how they respond to sun and shade, which is pretty cool. So, let's go. What do plants sound like? Well, we can know using this. This is a plant wave. This measures the electrical signals going through the leaves and stems of the plant, which gives us sound. And the sound can vary in level, in pitch, and tempo. So what I can do is I have these two electrodes, and when I clip these electrodes onto the leaves, the signal will be transmitted from this transmitter to a phone app that will let me hear the sound of the plant. So one we can clip here. So that's with one. So this is a plant that's mostly exposed to the sun. So the sound it's making is in response to the plant taking in solar energy, converting it into food for itself, which results in this sound. Pretty cool. Let's check out another plant. I'm way up here. So I'm up here in this tree to get some readings. Trees serve all sorts of purposes. They clean water, they take in carbon dioxide, and produce oxygen for us to breathe. They provide shelter for animals. They provide food from their branches. So I've got this already hooked up here, and it's making a very interesting whistling sound. And trees spread out in response to the trees that are around them. They can actually almost detect whether they have space to grow or not. So with this tree being out in the open, it grows and grows bigger and wider. And the more sunlight it catches, the more it can grow. Trees filter thousands and thousands of tons of carbon dioxide per year. In fact, trees produce up to 20% of the air we breathe in the world just in the Amazon rainforest alone. They're nature's air purifier. So this little branch that I've clipped onto is producing a whistling, sort of a call. Trees also have root systems that extend far into the ground to collect water. And the roots go so far down that trees can grow hundreds of feet tall. Well, the view's great from up here, but how am I gonna get down? So this is a pine tree. Is it going? It's a slightly different tone, which is interesting, because this plant is more in the shade, with a little bit of sunlight being absorbed. So if I can move it. Maybe I can play this tree. and me moving it changes the sound a little bit. Off to another plant. Maybe that'll get us something different. So it adapts a little bit differently. I hear more bells, I hear more pulses. So that indicates more activity. We got a prickly little weed here. I hear a lot more bells. This one's active too. Probably because they sprout so fast. And they grow and grow and spread and spread. So the stronger the electrical pulses and the more frequently they occur, it changes the pitch of the sound. So these are some small wildflowers growing next to the flowers over here. So we're gonna check these out. And it looks like it's getting some electrical pulses already. So I'm clamping it on the stem. We can try and mix and match what plants we're getting too. So these are mostly grown, but I'm sure if we let these grow and grow taller, they can end up like these guys, which stand about a foot off the ground. It's almost a smaller sound, where it kind of blends in, it's smoother with the rest of these low-growing plants. It's a soothing pitch too. Wow. So, we've changed our clips for these electrode pads. These cover a wider area on the plant and will get us a more accurate signal. So we take these coverings off, we stick one on this leaf, press it down, same for the other one. So now that we have both pads, when I put one pad on, it started to respond a little bit. But when I put the second pad on, the whole sound came together. It sounded a lot like the taller bushes and flowers that we measured before. And this is a partially shaded bush, so that's probably where it's coming from. When a plant grows, its roots spread into the soil and prevent the soil or sand or whatever it's affixed to from eroding. That's why in deserts we're trying to help protect trees like this, to prevent soil from washing away and turning into desert, a process called desertification. Even though we plant artificial landscapes with trees and bushes and everything, it's important that we protect our natural environment by not over deforesting an area. That way, we have plants and bushes like these for our children and grandchildren to look after.
Easier than that toothpaste one.
So this plant here has probably seen better days. As you can see, it's a little bit overexposed from the sun, a little bit of rotting going on in the edges of the leaves, but it's still making its own sound. Now, being next to other plants isn't necessarily a bad thing, but when bugs and other wildlife eat the plants, then it grays the leaves out like this. The leaves are more coarse. I'm sure a little rain would go a long way in helping this guy out. Plants also heavily depend on the water cycle for to consistently replenish and to regrow. Plants also have different shaped leaves to catch water. Even plants such as a cactus that only have needles only need to take in a small amount of water. So plants have adapted to have bigger leaves in certain climates and smaller leaves in others. So this one has about average sized leaves. There's evergreen trees that lose their needles. Some plants wither away or lose their leaves, but regrow in the summer. I'm sure if we were to do this in the winter, we would get a slightly different sound. Some plants have edible leaves. For example, the eucalyptus plant is eaten by koalas. Come down.
You got this?
I might just have to tuck and roll a little bit.
Tuck and roll. Watch out for the camera. Oh, Professor Baller's coming.
Oh, God. Professor Meatball.
Yeah, oh.
Okay, we're good. I'm way up here.
Now let's go do some plants over there.